All right, so we have an evaluation tomorrow, a short one. Then we move on to the gas stoichiometry. So this is perhaps just a simple presumption. Okay. Other things are more important than this. Is that what we can presume? Okay. All right. And one of the things that we do at the senior level, and they would agree, and it's not the first time that we've done this, students in the past decide to come up here and explain it to the rest of the class. Is that anybody in here? Well, you don't have to be a teacher. You just have to be able to convey and relay knowledge to your classmates. Because one of the things, you might say, well, we're not ever going to use this. Okay, that's maybe a possibility. But the work ethic, how many times have you heard those two words these last 2 or 3 years? A lot. Okay? Because we want you to be able to take this knowledge and work ethic and apply it to your future. Okay. So when we look at this, I would say it's your opportunity to participate, follow along, and I would, but we're juniors now. I don't know if we need to be told everything to do within a class because it's a choice, just like electing to be in here. Okay. So just in case we can't read that if we're looking online a little later, what is the average pressure in a piston when it is condensed from the previous expansion, which is 389 degrees Kelvin? Okay, so, and 25 cubic centimeters. As water is dumped into the block, the temperature is 410 degrees Kelvin, 90 cubic centimeters, and almost 3 atmospheres. So, this is probably one of the, you could say, greater inventions in the 18th century. About what time frame would that be when we say 18th century? Then that would be the 19th century. Be the 17th century. Okay? Because when you start out at Anno Dominion, okay, what does that mean to you? You ever heard of Anno Dominion?
I have not.
I bet you have, you just didn't know how to apply it. So, for anyone who's involved in history, and of course everyone can pick what events that have happened in history that had probably the biggest impact on the world, and you could compile your list, but probably 3 of the biggest aspects that have an effect on us and our society. 1, birthplace. The birth of Christ is 1, okay? And perhaps what you studied last year when it was bacteria and viruses, approximately the 15th century. What was wrong with the world over in Europe? The black or bubonic plague. That would be maybe another event that shaped history. And then, you want to take a guess what other event maybe? No. Well, that's a little more recent. We're talking about a little more history. Starts with a W.
Second letter?
W.
World War II.
World War I. I think a lot of historians would agree that World War II is just a byproduct of how World War I was settled. But anyway, those 3 events, okay? Birth of Christ, okay? Which, if you're going to measure time, you have to start at the year 0. So anything that happened before 0 might be 10 BC, 10 years before Christ. Then, as you get up to the year 0, from 0 to 100 would be the first century. Then if we say the second century, okay, that would mean year 101 to 199. That's why when you're pertaining to centuries, we say the 18th century means somewhere around the somewhere in the 1700s, okay? So if we're talking about the 18th century, what might this be an application because of looking at this and talking about gases? Change the world. This type of engine. Steam engine. That's right. So the reason that's important is because we say change the world because of transportation, which would be commerce, just because of being able to transport goods from one side of the country to the other. So even this application of the combined gas law, we're talking about that of steam engines. So as we look at this, what do we know in this problem? Because one of the things you're going to want to think about is what is the average pressure in a piston when it condenses from the previous expansion? So we don't know what the previous expansion is. So that might or must be which pressure then? To start with, which means what? Okay. So then here we're talking about pressure 1. Usually we put that at the end, don't we? Well, we can put it here. Because we don't know. It's asking for the previous expansion. So then 389 degrees Kelvin must be a what? Okay, do we have anything else? Of course. We have this type of volume, which volume 1. Okay, so then as water is dumped into the block, it's not that you dump that into the pistons, no. What has to happen in a steam engine, you have to be able to cool that down. So when you dump that in there, it cools the engine down so you can move on to your next expansion. Because if you did not do that, the boiler in the engine is going to do what eventually if it doesn't ever cool down? It's going to blow up, and bad things would obviously happen if that was to take place, a boiler explosion. Okay, so then if we have our initial set of conditions, we have 3 new conditions here, which must mean the next expansion, because here we're talking about the previous one. Okay, so volume 2, pressure 2, and then temperature 2. Okay, so volume 2 looks like it's 90. Okay, pressure 2 is 2.89 atmosphere. And then temperature 2 is 389 degrees Kelvin. And see, we did that pause there? Yeah. I was just about ready to turn around and see if we're actually paying attention. Yeah. Okay. It'd look kind of silly if we left those two if we know there's supposed to be a temperature drop. Okay, so 410 degrees Kelvin. So how many of you, once you get this information, is it all downhill from there? Yeah. Once you get your conditions, you just do what the formula tells you to do. So, okay, so it's the reading part that's difficult. Yeah. Okay.
It's the knowing what.
Okay.
When you had to convert them, that just makes it 10 times worse.
Now we know how to change this, Mr. Wagner. Now we know. Now we know their weakness. I don't know. That's not a weakness. That's just an annoyance. We get paid to be annoying. And you do it so well. Okay. It's experience. Okay. So what is on the left-hand side of that equal sign? Okay. So okay, did we or did we not address that when we started class? I mean, Are we not in 11th grade? I thought we were juniors in 11th grade. I didn't think we're in 3rd or 4th grade. Am I incorrect? I want to give you the benefit of the doubt. Okay, so there we've got our first volume, our first pressure over our first temperature, 389. Okay, so it goes on the right-hand side in that fraction. Looks like we got 90. What else? How about 2.89? And then I bet it's 410. Didn't even have to look. There's 389 is there. So then, to me, the best way to do this is get rid of that fraction. Okay? And what you're doing is, you probably have figured this out. You do that, okay? And then do that. I'm trying to make this not look like a very inappropriate symbol. I don't think that's what it would look like. Okay. Since we talked about World War II, okay? It's not my intention to draw a sign like that. Okay, so 410 times 25, okay? Okay. 10250. Okay, so that just comes from 25 times 410. Carry your variable. So if we multiply it across here, we have to do the same thing. Okay, 389 times 90 times 2.89. Of course, that gives you a really big number, 1011789. And to get P1 by itself, just like you did in physical science, okay, divide each side by what? Okay, those cancel. So, of course, you have to do it on that side as well. We divide by 10250. Okay. Okay.
Wait, which one did you get at the top?
I don't do it that way. This is, okay, because you're making a fraction, because I think you had asked that question yesterday.
You're divided. Which one did you get? 10, 25?
This one here, that's from taking 25 times 410, because your variable's right next to there. You have to take 25 times P1 is 25P, right? 25 times 410 gives you 10,250. That's where that comes from. I mean, there's nothing wrong. What Jace is saying take 25 times 410 and getting that number, and then you can put that on the bottom because that's what you're going to do anyway. You're just doing that 2 steps ahead of time. But that's not how we have taught you how to do that. Doesn't mean you can't. It just maybe makes it a little more confusing. Okay. Can we move on from that first problem? And I think part of the problem it's not what people are doing in here, it's what's leading up to this, okay? How did we start the day in here? I mean, what was it that I said that we started before class with those 2 desks? You remember? Clean them up. Take the Lysol wipes to them, okay? So it's a process of, okay, 1, you're probably getting worn down. It's just that time of year, right in the middle of the basketball season, okay? And sickness going around, okay? Wash your hands a lot, okay? Just because the surfaces that you touch end up on your face, and then once it's on your face, the chances of getting into a spot that you absorb it really increases. I don't know what that would be. It could be anything from on your skin, gets in your nose, and then gets absorbed into your bloodstream. That's what would make sense to me. Or your eyes, oddly enough. And certainly your mouth. Okay? If you do one of these things, and okay, I got to clean my mouth off now. Okay? All right. Yes, ma'am. Can we move on from this top problem? Okay. So one of the other aspects that's going to be really, really important when we start on Thursday is this will certainly be your friend. That just makes things a lot easier when we have gases that are measured at STP. Okay? Because then you can make certain presumptions that just makes that process a lot easier. There's still dimensional analysis that's involved, because what happens is eventually not all gases are going to be measured at STP. So when we're doing these problems, this is almost like we are starting with our composition stoichiometry. Do you remember that term from last semester? Composition stoichiometry would be, for instance, how many grams of nitrogen are in 300 grams of cobalt-3 nitrate. Something like that. Reaction stoichiometry would be if you had 18 grams of cobalt and, I don't know, we'll say 18 grams of, let's say, lead nitrate. I believe cobalt is a little more active than lead, so the activity series would say you got to swap partners in a single replacement reaction. Then you'd want to find your limiting reactant and how much of your cobalt nitrate being produced. Okay, that was reaction stoichiometry. When we get to, yes, that is right. And then when you do gas stoichiometry, there you are taking a solid of some form and converting it to a volume of gas, okay, which you don't know how to do because we have not taught you that yet. Okay. So what is the temperature of a gas as it cools from STP down to 3.14 liters and 0.79 atmospheres? The volume was 4.50 liters. So what can we presume? Can we erase this top problem? I think let's just get it out of the way. Okay, so we'll just use these variables here. Then, so how is it that we are starting with this? Because it says as it cools, okay, from STP. So if it happened from one set of variables or numbers to another one, what does that say about STP? Is that final conditions or initial, do you think? It's your initial conditions. So what is standard pressure? You can put 1 there. I usually do 1 atmosphere. Okay, what else would we know for STP? 273. What about STP for volume? Well, one's right, one's wrong. So the volume was 4.50. So that means that's where it started. So 4.50. Okay. Well, what does this tell you? Okay. Are we looking up here with our eyes closed or what? Oh, all right. No. That makes absolutely no sense. Okay? Okay. So it started at STP in that volume and went down to 3.14 liters. Okay? And 0.79 atmospheres. And then, what is the temperature? Okay. I was looking for a variable. I said, oh, I don't see another temperature on there. Well, We've already counted for 273.
I bet we're looking for it.
That we are. Okay? So, once you get it to here, okay, we'll go ahead and we'll knock that out. Okay. I'm sorry that bothers you.
Happy holidays. Coming up here, my favorite one.
Which one is that?
George Washington. What do you have for Valentine's Day?
Okay, agreed?
Sure.
So, if we agree, how did we do that? Oh, okay. Well, what did you write down to plug into your formula? That's exactly my point.
Well, you could do 1 times 4.5.
Yep. So, whatever it is your other conditions are, which is taking 273 times these two numbers, okay? And then dividing by your other variable. Is anyone confused? We can show you the entire process.
I'm down.
Do you want us to write this down, or are we good? Because some of you got this answer then. We're good? All right. Yes, ma'am.
On the thing tomorrow, or the quiz tomorrow, are there gonna be any conversions?
Oh, of course.
Like,
We can't have any fun without doing conversions. Oh, I don't know. Probably pressure to atmospheres. There's no manometer problems on there. Oh, shoot. I could have put that on there and said, surprise, but no, that's not on there. That's the J tube. Okay?
like, when we get from pastels to kilopastels?
Okay, so maybe if we had, I don't know.
I could go for a snow day.
Okay, so if we had that many pascals and we need to get that to atmospheres, okay? Now, this is just what I would suggest. Don't try to move the decimals in your head, okay? To me, the best thing, I think it comes out to 38 kilopascals, but I'm not quite sure. So that's why we're going to write it down and then see if it's 38 kilopascals, okay? So if we're going to change this to a whole number, okay, we've moved it to the right twice. How many more zeros? Okay, now that is pascals. We want kilopascals.
You need another zero. 3 zeros.
God, I thought I wrote. Honestly, it's not one where I said I was saying who's paying attention. I thought I wrote 3 on there. Okay, so now you've got it to here. How many kilopascals is that? 389, right? Right. So that's why earlier I said I think it's 38.9, which I originally thought it was, but now we got to move it back to make that pascals to kilopascals. So 389 kilopascals. And how do we change that to atmospheres now? So then upon doing that, it's probably maybe just a little over 3. Huh, a little more than just a little. Okay, I guess we can tackle the hardest one, changing Celsius to Kelvins.
Maybe
Difficult, isn't it?
Mine came back 297.84.
divided by 273.
Yeah. Do that tomorrow then. Yeah. Add 273. Is there anything else? Now, this is
When's the first
honest.
of the year?
Sorry?
When's the first of the month?
Thursday.
Oh.
Okay? This is just,
Well,
well, don't we know there's 31 days in January?
I didn't know that.
Of course, maybe we're just all used to looking at that board, and I just don't have it updated to first and second. Okay? Let's hope for a cloudy day on Friday. Groundhog's Day. Puxatawny Phil, if he sees a shadow, he's going to get scared and duck down into his hole and say, you got 6 more weeks of winter.
We haven't had enough winter.
That's if you are superstitious. But anyway, getting back to my original question. This is just,
Any more questions?
let's just ask you. Okay? Because as I'm looking out in the audience here,
Worksheets back from the other day? So you can use them to study.
I just collected them just now. We only had one paper over the combined gas law. I just collected it. Okay? That's why we go through these examples that you can study from. But what? Need what? Oh, so we can goof off more than what we do now in more of these examples?
Yeah.
Oh, see, that's why we don't do that. Okay, back to honest question. How many of you are not feeling well? Because I see a lot of droopy heads, we're tired. Is that a sign of we're just not feeling well because of sickness or illness going through the school? It's just a question. Okay? And I don't know if you want to call it a trifecta. I don't like trifecta. Trifecta, that makes more sense to me. These 3 things. 1, are you drinking enough water? A lot of you probably do. And probably the biggest one, are you getting your sleep/rest at night?
Yeah, I got 9 hours.
Okay? So that's also another choice. Drink more water, get more sleep. Okay?
Take more vitamin C.
And, okay, you could say take more ascorbic acid. Yep. All right. And then,
What's the recommended hours of sleep?
at your age, 8 to 9 hours. Okay? And then finally, the third one, which is some people are better at dealing with stress than others. That's just, some people can. Some people, when my observations in college, the exam is handed to them, and no big deal. Just put my name on there, be one of the first ones done, and get a 95%. Then there's other people who get the exam, and it's something, that was me. Yeah, I don't know. Just sounds good. All right, so combined gas law tomorrow. You have any problems? It's your responsibility to get extra help. We'll catch up to you next time.